I want to show you one last example of an absolute value equation before we get into the absolute value inequalities. And that's just because something kind of weird happens with this particular one. So if we start off with our same two questions, do we have an absolute value by itself on one side? Yeah. Is the other side non-negative? Yeah, because it's an absolute value. So we can use the absolute value property. And so we'd go with x plus 9 equals x minus 6, or x plus 9 equals the opposite of x minus 6. Great. So now we're going to try to solve these equations. Now for the one on the left, we try to get rid of this x on the right by subtracting x from both sides. In doing so, we're left with only 9 on the left and negative 6 on the right. Does 9 equal negative 6? No, it doesn't, no matter what x is. If this were our only part of the problem, we would say no solution. Now, this doesn't mean there's no solution. We still have that guy on the right to work with. But that equation didn't lead us to a solution. Let's solve the one on the right. So let's distribute the negative. Now if I add the x to both sides, I get 2x plus 9 equals 6. Then subtract the 9. Then divide by the 2. I get this answer x equals negative 3 halves. Now as we report this answer, we're not going to report no solution and negative 3 halves. That doesn't make sense. That's like saying, hey, what are your favorite colors? And for you to say blue and I have no favorite color. No, if your favorite color is blue, then you'll say my favorite color is blue. And same thing here. We're not going to say there are no solutions and here's one solution. That doesn't make any sense at all. We're just going to say we only get one answer this time, and that answer is negative 3 halves. Now let's try to make some sense on why this happens. Now, to make sense of why this happens, let's actually come back to our previous example of example 4. We got to see what graphically happens. If we go way, way back to example 1, when we first looked at these, graphically, we saw that we normally get two solutions because we were looking at where a horizontal line meets up with a v, with an absolute value. So going back to example 4, what was happening here is we had a v whose slope was 9, so we had a really steep v, and we had another v whose slope was 6, so it was a less steep v. They crossed in two places. So that's why we were getting two answers to example 4. For the example that we're working on right now, they both have a slope of 1 to them. So what's happening on this case is we have a v here and a v here that's parallel. So this line and this line are never going to cross, just as this line and this line are never going to cross. But where do our two v's cross at? In one spot. So they do cross in one spot, but where normally we'd be getting a second crossing, we don't get one because of the fact that they're parallel. And so that's what you can kind of look for to tell when this kind of weird thing's going to happen, when you can expect it, is when you notice that the coefficient in front of your x's are both the same. That's when you can say, oh, wait, I remember seeing that from the video. That's normal. That's expected that I only get one answer here.